today, I'd like to transition a little bit and just talk about the hot dip galvanized coating and the sustainability and how it can extend the service life for our infrastructure projects, including short span steel bridges, and in some environments provide over 100 years of service life. So I'd also like to discuss the sustainability of steel combined with zinc and how this particular coating option can help you achieve your sustainability goals. But first, I'd just like to introduce myself. My name is John Kraswicki. I work for the American Galvanizers Association. I'm the marketing director there. I've worked for them for over 7 years, starting as a corrosion engineer and ultimately now working as marketing director. Our association has been around for quite a long time, since 1933, and we serve as the unified voice for the after fabrication or batch hot dip galvanizing industry. And one of our main goals here at the AGA is to provide technical support to engineers, architects, and other specifiers or users of hot dip galvanized steel regarding the proper specification, design, and performance. So I encourage everyone on the line today, if you have questions about the galvanized steel and its use, please go ahead and reach out to me or our organization. We can help you out. Today's presentation is going to focus on steel and zinc and the sustainability of both of those materials used in combination. We're going to talk about the longevity that hot dip galvanizing provides for steel. We'll talk a little bit about the reuse and repurpose of hot dip galvanized steel and talk about the recyclability and the environmental and economic impacts of using hot dip galvanized steel. There are three primary tenets of hot dip galvanized steel's sustainability. First, it's essentially just steel and zinc. It's a zinc coating on top of steel. The zinc is essentially 98% the coating is comprised of about 98, 99% zinc. And it's just a coating on steel. Both of these elements are naturally occurring abundant elements that are found in the Earth's crust. So have widely abundant. They're also infinitely renewable resources as well. They can be recycled without a loss of properties, meaning that they can be used and recycled and reused in future projects. And the third tenet is the maintenance-free longevity that the hot dip galvanized coating can provide steel. This is going to ultimately minimize your future environmental and economic impacts over the life of the project. So I'll discuss each of these in detail today. But first off, as I mentioned, both steel and zinc are naturally occurring abundant elements in the Earth's crust. Iron or steel is the fourth most abundant element in the Earth's crust. Zinc, which comprises of 98% of the hot dip galvanized coating, is the 24th most abundant element. So both widely available abundant materials. But zinc naturally exists in air, water, and soil, as most rocks and minerals contain zinc in varying amounts. Soil naturally contains levels of zinc. Organisms need zinc to live. Vital functions of the body in both animals and humans require zinc to properly function. There's more than 5.8 million tons of zinc that are naturally cycled throughout the environment each year by plants, animal life, rainfall, and other natural phenomenon. Zinc's also found in common household products as well as sunscreens, makeups. It's used in the tire manufacturing process. So both elements are widely used throughout society in a variety of different products. Both steel and zinc are both highly recyclable. They're both 100% recyclable without loss of properties, loss of physical or chemical properties. They can be multi-cycled. That means they can be recycled over and over again without losing its properties. They can be used again and again without compromising their integrity. A large portion of the steel that's used today comes from recycled sources. And also a large supply of zinc comes from recycled sources as well. And these are both ever increasing. Both industries are constantly looking for new ways to reincorporate the recycled products back into new products. So these rates have increased over the years. But one of the unique things about these two particular elements are that they also have high reclamation rates, meaning that they can be reclaimed from a product and put right back into use. So virtually 100% of steel is reclaimed at the end of its life and recycled and put back in to future steel. And that holds true for galvanized steel as well. The zinc can be recovered from the steel, and it can be recovered while it's recycled. It can be refined back into zinc and sold back to the galvanizer to use again to coat more steel on future projects. The third tenet of sustainability that I showed earlier would just be longevity. The hot dip galvanized coating is known for its maintenance-free longevity and provides decades of corrosion resistance. It's been around for 150 years. So the good thing about that is we have lots of data out there surrounding the performance of galvanized steel in many environments. And so we use this data to produce this chart to give everybody an avenue to estimate the service life of hot dip galvanized coatings in many environments. And so we've been collecting corrosion rate data around the world for well over 50 years. All of this data was put into a database, and we built a tool to access that database and to use environmental and weather parameters that you can input into this zinc coating life predictor, and it will estimate a corrosion rate. And so we did this to produce this chart. We basically went around the country and assigned cities to each of these environmental classifications, cities that best represented an industrial, tropical marine, temperate marine, suburban, and rural environments. We gathered the weather and atmospheric data in each of those cities, and we use that data, we input it into our zinc coating life predictor, which uses real world data, and we extracted these curves to show and estimate the service life of zinc. And so what this chart shows you is the time to first maintenance for a hot dip galvanized coating. And so this would be defined as the time when there's 5% of the rusting of the steel surface. So in some situations, maybe even more of the steel surface could rust, and that could be okay. So this is just an indication of when you would want to start looking into the maintenance of the hot dip galvanized coating. Most hot dip galvanized coatings on bridges and thicker structural steel, you're going to get at least a 4 mil coating on that type of steel, sometimes even higher than that. But as you can see from the curves here, even a 4 mil coating in any one of these environments that we modeled here on this curve will give you at least 70 years life. And again, that's only the 5% rusting of the steel surface. For bridges, in some situations, you may be okay with 10, 15, 20% of the rusting of the steel surface before you would consider replacement or repair or maintenance. And so you could really even exceed these service lives that you see on the chart here. We did just update our zinc coating life predictor. So just a quick plug on that tool. I put the website address on these slides. Everybody will receive a copy of this slide deck after today's presentation, or by Friday, actually, excuse me. But I encourage everyone to go ahead and check that tool out. We've just updated it to a nice modern new design. It has a reference section. If you pull environmental and atmospheric data in your local area, you can input it into this tool, and it'll estimate a corrosion rate of zinc in your area. Now shifting gears a little bit, let's take a look at the hot dip galvanizing environmental impact and how that can be quantified. And we've done that through two different documents that we produce. First, we looked at a health product declaration, which is essentially a safety data sheet for products to compare the chemical inventory of those products. And they're specific to each manufacturer typically, but for hot dip galvanizing, it's simplified because zinc is the key to this. If you're looking into what's the composition of hot dip galvanized steel, you're going to have your steel component, but then you're going to have the zinc on top of the steel. And so really we need to look at the zinc to determine what the composition of that is. And so our galvanizing members in North America typically use either high grade or special high grade zinc. This is zinc that's at least 99% pure with a few trace impurities. There are a couple galvanizers, not that I'm familiar with, that use Prime Western zinc, which is 98% pure zinc. It's rarely used, if at all, in the industry anymore. There's been a real commitment in the hot dip galvanizing industry to use the purest levels of zinc And so you can find out some information or download these health product declarations on the website listed on the slide there, or also by visiting our website at galvanizeit.org/HPD. So beyond the actual composition of the coating, we also conducted a study to determine what's the impact of all the raw materials and the emissions during the production of the galvanized steel and the components that make up galvanized steel, such as the steel making process and the zinc refining and smelting process as well. And so we conducted an EPD study. This is a cradle-to-gate study that analyzes just what I mentioned there, the production stages of producing the raw materials, the transport of these raw materials to the galvanizing facility. And we collected data from our galvanizing members and the zinc industry and the steel industry to try to quantify these environmental impacts. We contracted a company called Sphera to conduct the study, and we also had it verified by UL Environment. All of these are EPDs must fall into a product category rule. For our particular study, we use the North American Designated Steel Construction Products category. You can see the picture of the report on the right side of the screen there. You can get a copy of that by visiting that webpage listed on the slide there. But let's dive into that report a little bit and talk about a few specifics. And so here's what we analyzed during our EPD study. So we looked at the raw material supply. We looked at the steel mills producing the basic steel shapes and products, the transportation of the steel to the fabrication facility where that steel is then fabricated into specific shapes. All of that has to get to the galvanizing plant. And we also looked at the zinc supply for the galvanizers. We're applying zinc to steel. So those are the two raw materials included in this process. And so looked at the zinc mining and refining process and the transportation to the galvanizing facility. All of that's included, as well as the actual galvanizing process itself. So we looked at the emissions that from all of these particular processes, all of the raw materials used in all of these particular processes to really quantify what's the environmental impact of the hot dip galvanized coating. And I think it's best summed up with this slide here. This is, we won't go cover everything in the EPD, if you can download it if you like, but one of the biggest questions I get asked is on the global warming potential or the embodied carbon, the impacts of that, of galvanizing on that particular metric there. And so this slide does a good job of explaining that. So as you can see, this is the relative contribution to the total embodied carbon amount or the global warming potential for structural steel, plate, and hollow structural sections as well. And so we got our steel numbers from AISI and AISC, and we also got the galvanizing numbers from our galvanizing members. And as you can see, the hot dip galvanizing component for each of these accounts for a small percentage of the overall impact. And so by specifying hot dip galvanizing for your steel, you're adding a very minimal amount of embodied carbon to the overall process. And so, and for this increased amount of embodied carbon or global warming potential that you're adding to this product, you're receiving a lot of longevity. Galvanizing is going to make the steel last a lot longer, so that you're going to receive a direct benefit for increasing this. But as you can see, the hot dip galvanizing accounts for a very minimal component of the overall final finished product. I think the EPD is a little short-sighted because it just looks at the production side of things. It doesn't consider the use phase or the end of life of products. And so to really round out this picture and highlight some of the other advantages of using hot dip galvanized steel, we have to look at the total life or the life cycle assessment of the product. And so you can see with this process flow diagram describes that. On the left side, we can see the production phase. We have quantified that with our EPD. But when the product actually gets into service, one of the unique things about the galvanized coating is it rarely requires any maintenance. And so essentially, you're not going to have to put any more energy or materials into the galvanized coating when it's being used. And from that other chart I showed everyone earlier, we know that galvanizing can last 70 years or longer in many environments. This is often going to outlive the actual service life of the structure. And so there's going to be zero inputs during the use phase of its life. There's going to be a small amount of emissions in the form of zinc corrosion products. These are going to be zinc oxide, zinc hydroxide, zinc carbonate. These are relatively benign products. Zinc oxides used in sunscreens, things of that nature, and other common products that we use on our bodies and at our houses. So just a minimal impact from that. And then at the end of life, there is going to be some energy required to demolish and disassemble the structure and take it down. But due to the fact that steel and zinc are so recyclable, you're going to be able to send and salvage all of that product and send it right back into the production phase. And so we can see that this cradle to cradle process is a much better represents the sustainability of galvanizing much better, because instead of cradle to gate, we're looking at cradle to cradle. We're going all the way through end of life, and it's a really a cyclical kind of a process here. Other factors that make galvanized steel sustainable are its ability to be reused. It lasts so long in so many environments that you can reuse it. You can either reuse it without reprocessing, such as an example I'll show you next. You can recoat and reuse it. If the zinc coating has corroded to a level, maybe down to that 5–10% steel surface rusting level, you can definitely disassemble the galvanized steel and regalvanize it and reassemble it. That has been done on some projects, probably not too practical for a bridge itself, but maybe for some bridge railing or things like that. And so these two avenues allow you the ability to save additional resources and energy by being able to repurpose or reuse galvanized steel. It's also going to reduce the environmental impacts and save money on the life of the project as well. I showed this example quite often, so some of you may have seen it before, but it's my favorite for talking about the repurpose or reusability of galvanized steel. This bridge has two lives. So this bridge was once the Fore River Bridge in Quincy, Massachusetts. They built a temporary bridge structure while they were wanted to do a full replacement of a bridge in Massachusetts, and so they erected this, again, temporary bridge structure for 15 years while they were building the main bridge. The contractor who won the demolition award for this temporary bridge structure disassembled the bridge and stored it on his lot and noticed, hey, this galvanized coating is still pretty all intact. It's pretty durable. They measured the coating thickness. There's still a lot of coating left on it, only 15 years of service. So what are we going to do with this? And so they decided to use the bridge in their humanitarian efforts. He also had a foundation that did humanitarian work down in Haiti. And so what they did was they disassembled the bridge, they put it on a barge, and they shipped it down to Haiti, and they reconstructed this bridge. And so it had a second life. And so why could they do this? Well, because in addition to hot dip galvanized coatings being incredibly corrosion resistant, they're also incredibly durable as well. We have these intermetallic layers that form on the coating, which actually end up harder than the base steel. So it can withstand the rigors of demolishing and transporting on barges and re-erection. It also, the coating forms perpendicular to the surface. So even on corners and edges, which oftentimes is the most vulnerable area for corrosion to begin on steel structures, due to the intermetallic layers forming and the metallurgical reaction that produces the coating, we get the same thickness. It also fully coats internal pieces as well, internal structures and around threads as well. So the durable coating allowed this bridge to become a new bridge down the road, down in Haiti here. So this is the reconstruction of that Fore River Bridge. Sections of that bridge were reconstructed into the Rivière-Cauchon-Grasse Bridge in Haiti, and they are actually building several bridges down there now. This is one of the first ones they did, but they're constructing many more using that same steel from the Fore River Bridge in Massachusetts. I mentioned earlier that galvanized steel can be Reprocessed as well. This is an example of that. You're not going to probably reprocess a whole bridge by demolishing it, taking it down and regalvanizing it, but you can certain components such as the bridge railing here. This bridge railing was in service for nearly 50 years, and they had to do some upgrades to it. There was some crashes and accidents that damaged sections of this bridge railing. And so, but they did notice that the galvanized coating lasted really well in this environment. So instead of buying new steel and putting up entirely new railing, they just took this railing down, stripped off the remaining galvanized coating, regalvanized it, and put it right back up. And so it saved them a ton of money not having to buy new steel. And one of the biggest aspects of why galvanizing is sustainable is its economic advantages it can provide to the life cycle cost of a project. And so what I'd like to do quickly here towards the end of my presentation is just demo another tool, not really demo, but I'll show you another tool that we have built to quantify the life cycle costs and compare life cycle costs of various corrosion protectant systems to one another. And so we built a calculator that uses inputs. It uses data from the paint industry. We used a KTA Tater paper that quantifies all of the costs of painting and maintenance over the life of various structures. We polled our galvanizing members to get galvanizing costs. And we put all that into a calculator that can be found at lccc.galvanizeit.org. And I want to show you a quick example of that today, because this really accentuates how much money and materials and time can be put into corrosion protection over the life of a bridge. So for this particular example, let's assume that we have a typical mix of structural steel sizes and shapes for this bridge. Let's assume it's a 200-ton project. We want to get at least a 70-year design life out of this. It's going to be installed in a moderately industrial environment, and also going to assume some different surface prep and application methods for the paint. And so what our tool does, I'm going to, instead of doing a full demo, I'll show you a couple screenshots of it today, but I encourage everyone on the webinar today to please check this out. So first off, you're going to be able to input and compare hot dip galvanizing to various different corrosion protection systems. And so you can use this drop-down menu, select coating systems that you want to compare hot dip galvanizing to. Next, we're going to put in some parameters regarding the currency, the cost, and the time value of money, because we are doing a life cycle analysis. It's then going to ask for some particular project specifications. How big is the project? How many years do you want it to last, et cetera? What kind of environment is it going to be in? But the final, after you get through all of these steps, what you see on the right side of the screen is an output of the cost. And so you can really get specific and do an example that's really credible to your particular project and customize this report. So you can really see how galvanizing stacks up against some of the other corrosion protection systems. I know we can't read this very well right here, so I put it on another slide. I did an analysis of using these project parameters here and compared hot dip galvanizing to various paint systems. I also threw in a duplex systems into this example. So that's galvanizing plus paint. And I also threw in zinc metallizing or thermal spray zinc. That is picking up some momentum in the industry as a viable corrosion protection system. So as we can see on the slide here, if we look here, this is on an initial cost basis. So just the initial application of all of these coating systems, we can see that even hot dip galvanizing is the lowest cost on this slide. But you know, if you can also input your own galvanizing costs as well, if you have a specific quote on that. But the real result here is when we look at the life cycle costs. So over the life of this structure, we're going to be for the paint systems, we're going to be applying more paint. We're going to be applying maintenance repaint, full repaints, et cetera. So over the life, we're going to be adding cost into these corrosion protection systems over the 70 years. With galvanizing, our first cost is our last cost, because we saw earlier the slide with the chart in this moderately industrial environment, galvanizing is going to last 72 years at least with a 4 mil coating. So we're not going to have to maintain the galvanized coating at all with these other paint systems, we are going to have to apply paint over and over again throughout the life. And you can see it really blows up the overall life cycle costs of the corrosion protection system here. And one other interesting thing to note is the duplex system, galvanizing plus paint, actually becomes the second most economical coating system in this example. And that is because the galvanized coating extends the maintenance cycles of the painting. It lengthens the cycles out so that if a normal coating was going to last 7 years on steel, you might not have to maintain it till 10 years on galvanized steel. Zinc corrodes slower than steel, so it's going to prevent that underfilm corrosion and slow that down. And so we can really see the effects of that here as applying paint on top of galvanizing really reduces those maintenance painting cycles there. So in closing today, just want to summarize a little bit. Steel and zinc are both naturally occurring, abundant, highly recyclable materials. And hot dip galvanizing's maintenance-free longevity provides both environmental and economic benefits, because if you're reducing the maintenance over the life of the structure, that means you're going to be using less energy and resources and have less emissions over the life. It's going to free up capital for other projects by not having to maintain the corrosion protection system.